Good morning to all of you, my dear students. Now we will see the exercises in simulation and analysis lab of final year mechanical engineering ME exam number 1. As for the analysis syllabus, I gave the exercises. The first exercise is find the deflection and stresses of a given bar by discretizing into 3 equal elements using ANSYS Classic experiment number 1A. This is the bar model which is being fixed at the top, and the load is applied at the bottom towards downward direction, 300 mm length, 50 mm width and 10 mm thickness. The force P is 10 kN which is applied at the free end. So for this model, how we can solve it in ANSYS, let us see now. In the ANSYS Classic, this is a student session model, ANSYS 2020 R2. For this model, I will be explaining you the concept in the laboratory if you have ANSYS 12.2 or 15 or whatever it may be. With that particular model, with that version, you just identify the element type, suitable element type, then you can proceed, because there may be a slight variation in the element type according to the version. So now in this model, I am doing the first model. Before going into that, to do the analysis, first we will select file, clear, start new. Do not read file, okay, yes. Then I will change the directory. Already we have created a folder. I have created a folder in one of the directory, and in the local disk F I have created GEIT ME8 under simulation and analysis lab, and exercise number 1A I am taking it. Okay. Save database, preference, structure, okay. Preprocessor, add. Material library, select units. This is not required, temperature. Select units, user, okay. Then material models, structural, linear, elastic, isotropic, 2/5. Poisson's ratio is 0.3, which is given in the question itself. Okay, save database. And then sections, like add 1, okay, cross section area is 50 by 10, 500, okay. I am giving it everything in user unit, that is in millimeters. Next, all the length parameters are in millimeters. I am giving modeling, create, key points, inactive coordinates, first point, default. Second point, I am applying at a distance of minus 300 mm in the y direction. And then lines, inactive coordinates. I am selecting the first and last point. Okay. Now meshing, mesh tool. I am selecting the lines set, apply. So this is actually, we need to give this one for how many number of elements do you need it. Particularly if you need 3 elements or 4 elements, in that case we have to give this value. Otherwise, you can directly click the mesh button and you can select the line, and ANSYS will automatically discretize and make a mesh up to 10 elements or 12 elements according to the analysis of the structure by itself. But if we need particularly the number of elements, then we have to define it. Okay. And meshing it. Okay, now the meshing has been done. If you want to see this, plot, multi-plot, there will be a white dots, you can find it, but I will show it in another way. Plot controls, numbering node numbers on, you can find it. This is node number 1 and this is node number 2. So 3 and 4 is existing in between, 1 and 2. Totally 3 elements are there and 4 nodes are there. Then up to this we have finished a preprocessor. In ANSYS totally we have to do 3. One is 3 phases, means preprocessor, solution, post-processor. Now what we have done up to now is a preprocessor stage. The next one, solution, where we have to define the loads and constraints here, and then we have to solve. Define loads, applies. Normally in analysis type, normally it will be in static analysis. This is a static analysis what we are doing right now. If we need to go for model harmonic transient and all, in that case we have to change this radio button. Okay. Now by default it is taking the analysis type is static right now, so we don't need to go inside of that particular category. I am coming to apply structural displacement on nodes, selecting the first node, apply all degrees of freedom, because it is completely fixed, so we are giving all degrees of freedom. Otherwise, based upon the constraint given in the question, we have to give the constraints here. Then force or nodes on nodes, I am giving the node second, y direction, the load is acting downward direction nearly 10,000 Newton. Okay, it is showing in the red color arrow mark. Okay, saved database. Everything we have given. We are asking the ANSYS to solve current load setup, current LS. Okay, the getting solution is done. Once you get the solution is done, that's what we have did. Everything is right. Close. Compartment default. Suppose if we make any mistakes in ANSYS, it will show with some warning yellow mark. But if we have made a big mistake, ANSYS will shut down. That's the thing. We should know that one. Now, plot controls, alt copy to file. Right now I am saving this particular model as my base model, as my the path model, which I am taking it for the analysis actually, a one-dimensional model. Okay, I have saved it. Next, general post processor. This is the third stage of ANSYS, through which we will be getting the output whatever we require. Plot results deformed shape, deformed plus undeformed. Now I am getting both deformed plus undeformed. The white color mark shows that it is undeformed portion of a rod model which we gave it in the beginning. The blue color mark indicates the deformed one. So the maximum deformation is 0.03 at node 2. Okay. So this particular deflection is obtained by applying the loads and constraints with the given model with the given material conditions. Okay. Plot controls, alt copy to file. Okay. Now again, I am just taking that deflection value, DF solution displacement vector sum, and different values at different nodes. So the highest deflection is existing at the free node red mark, the lowest is at the fixed end 0. But normally it is not 0 at the fixed end, it is very small deflection which is negligible, so we will not consider it. And the way we are calculating in finite element analysis, the same way it is being adopted here also, assuming that the fixed end is 0. Otherwise, in FEA by penalty approach, if we go there, and we can able to find out the deflection in the fixed end also, but that will be very small, negligible. Okay, I am just saving this particular value also. Okay, so if I need the data in a tabular form, so I can take this nodal solution, degree of solution, displacement vectors. I will be getting the table. I can save this one as a file, save as. I will be going into the same drive where we have started the analysis. In the beginning of the analysis, we gave this folder here, all deflections or deformations we can give it. So this will be saved. Here we can find it at node 1, it is 0, the UY direction. Normally to find out the deflections in the y direction, we don't need to go for displacement vector sum. We can give it directly displacement in the y direction, but I am giving displacement vector sum so that you can understand that what is the value ANSYS is giving here. UX is completely 0 because we are given the load only in y direction. UZ is also 0. The UY we have given node 1 deflection is 0, node 2 minus 0.3 e power minus 1 is minus 0.03. The minus sign indicates downward direction, displacement values. Node 3 is existing in between node 1 and node 2. That is minus 0.1 e power minus 1, minus 0.01. And node 4 is 0.02. Means the value which is indicated here, I can show it this way. The node 1 is this one, it is completely 0. Node 2 is the last portion, minus 0.03. Node 3 is minus 0.01 and node 4 is minus 0.02. So 0, 0.01, 0.02, 0.03. These are the 4 deflections we have arrived. Okay, so that's how. Closing the window. Still, after this we want to find out the stresses in the given bar model. In that case, we will be going for element table, define table, add by sequence numbering. We have to select the LS one. By sequence numbering, we have to select LS and we have to apply 1, and then we can find out the solution for the stresses. That is for the given model. That is another portion of our question. These deflection stresses they have asked. By closing ANSYS, we should save everything. Then okay, that's how we have solved everything. Thank you.